And we're back for part 2 of dimensional analysis. This is the 1.04 application that is due for this assignment before you do the quiz. You want to do this a couple times maybe just to get it down, unless that setup of equation comes easily to you. So try problem number 1 and then come back and watch the video and make sure you got it. If not, turn off the video again after you correct your work and try it again, and then keep going through that process until you have the odds perfectly down, and then do your evens. Okay, so for the odds, how many days is 1430 miles? So let's rewrite this. 1430 minutes is my known because it's the one with the number, and my unknown is how many days. So I'm going from minutes to days. So my pathway here, minutes to days. To find out the conversion from minutes to days, because then I'm not going to give you that answer. Okay, so do make sure that you have the whole process. Minutes can be converted to hours, and hours can be converted to days. And you might even want to write down over here to make sure that you have it and you don't write it backwards. Well, 60 minutes is 1 hour, 24 hours equals 1 day. Okay, so you want to be showing all this part so that you get full credit. You have to show your work for full credit. If there's no work, you're going to get a 0.1 on it and be asked to redo it. And if you turn it in late, yes, you get late fees on it. If you show your work and you kind of went off track, then you're going to get some points back that way. But the best thing to do is to follow this format here. Known equals question mark, unknown, and path, because that's going to maximize your points if you go off track. Setup of equation, known over 1. And how many things do I have? I'm going from minutes to hours and then hours to days. So I'm going to have 2 unit conversions. Known over 1 times 2 over from times 2 over from. Okay. My known is the one that's on the left side, 1430 minutes. Okay. And we're going from minutes to hours. And then my second conversion, we're going from hours to days. So I've now converted it. So it's 1430 minutes over 1 times hours over minutes times days over hours. So that first unit conversion or the second fraction, so do be aware, this is called the start, unit conversion 1, unit conversion 2, even though this is fraction 1, fraction 2, and fraction 3. Make sure you know that difference for the quiz. Okay. And how many minutes are in an hour? 60 minutes are in an hour. So it's 1 over 60 on the unit conversion number 1. And there are 24 hours in a day. So it's 1 over 24 for unit conversion number 2. And then that gives me 1430 times 1 in the numerator and 1 times 60 times 24 in the denominator. Plug that into Desmos, whatever, or your calculator. And then your answer, you're going to round to 3 sig figs. Right. Number 3, the molar mass of a new prescription drug is 287.34 grams per moles. If the manufacturer produces 537 moles of the drug, how many grams? Now there's 2 sets of numbers, but what is this set of numbers? That's the unit conversion. So we're not going to use that as our known. The number that we're converting is our known, and the how many is our unknown. 537 moles is equal to how many grams? We're going from moles to grams. So our unit conversion is that 287.34 grams per mole. Now that one doesn't look like it's a conversion. Let's rewrite it so it is 287.34 grams equals 1 mole. Then maybe it's in a little bit better format for you to see. And set up our equation, known over 1. And then from goes on the bottom, 2 goes on the top. We're getting rid of or dividing out the from, and we're multiplying in the 2. Our known, 537 moles. Our from is moles. Our 2 is grams. There are 287.34 grams in 1 mole. So we are just going to multiply 537 times 287.34. And that gives us 154,301.58. Now that's really specific, but our problem was not that specific. There was only 3 sig figs here. So underline the first 3 sig figs, and that is the 1, the 5, and the 4. The 4 is in the thousands place. So we are going to round to the nearest thousand. 154,000 would be your answer, not 154. If I had $154,000 and the bank told me here's 154, we're square, we would not be happy. They would have owed me a lot of money there. So when you're rounding, make sure you're still keeping it in that same size or value. And number 5, a molecule of oxygen has a speed of 473 meters per second at a certain temperature. Okay, determine the speed of the molecule in kilometers per hour. 437 meters per second. Remember when I did that problem on the last class? Set it up not as a diagonal divided. Set it up this way so it's easier to figure out. 473 meters over 1 second is equal to how many kilometers over hours? Okay, so that's going to help our process. Now, when we do the pathway here, we have to go meters to kilometers, and we have to go seconds to hours. So we have 2 different sets to do. When we meters to kilometers is the top. 1 kilometer is 1,000 meters. And the bottom is seconds to hours. That one needs 2, doesn't it? Seconds to minutes, and then minutes to hours. And there are 60 seconds in 1 minute, and they are 60 minutes in 1 hour. So those are the conversions that we're going to need. So our setup of our equation is a little bit different, but it's still known over 1, 473 meters over 1 second times the unit conversion. We're going to go meters to kilometers first. From meters to kilometers. 1,000 meters in a kilometer. That's unit conversion number 1, and our numerator is now taken care of. The denominator is on the bottom, so it works backwards. So we're going to go seconds to minutes first, where seconds are going to go on the top and our minutes on the bottom. Why? Because we have to be able to cancel our seconds. If I put it the other way around, I would have seconds squared on the bottom, and that would not have worked. Okay. And there are 60 seconds in 1 minute. And now my second part is minutes to hours. So minutes goes on the top and hours on the bottom. That way my minutes cancel, and there's 60 minutes in 1 hour. 473 times 1 times 60 times 60 is my numerator. 1 times 1,000 times 1 times 1 is my denominator. And so when I plug that in, I am getting 1702.8 kilometers per hour. Am I done? Substitute, solve, sig figs. 3 sig figs there. Okay, so I have 3 sig figs. So I'm going to underline the first 3. Notice that's a 0, but it still gets underlined. Why? Because it's a trapped or contained 0. So in this case, I'm going to be rounding to the nearest 10. 1702 rounded to the nearest 10 is not 1710. Which one's closer? 1700. 1700 kilometers per hour. Okay. Now, that one's kind of a trick question. If you do answer 1700 kilometers per hour, I will give you full credit for year 1. But when I look at 1700, how many sig figs are there? Only 2. Trailing zeros, if I don't see a decimal, are not important. So how can I get 3 sig figs? Some people want to add a dot at the end. I could, but now how many sig figs do I have? 4. What's the easiest way? 1.70 times 10 to the third. Change it to scientific notation. And now I have my 3 sig figs. And that's all for this video. Have a great day.